Smoothing an image looks like a simple neighborhood search, but if you're calculating the same sums over and over, you're wasting cycles. The real trick here is using a 2D prefix sum to turn a repeated area search into a simple subtraction problem. The goal is to create a blurred version of a grid. For every cell, we need to find the average of it and all its surrounding neighbors, then round down to the nearest integer. Imagine a 3x3 grid of ones with a 0 in the center. For the middle cell, we'd sum all 9 cells, divide by 9, and get 0. For a corner cell, we only average the 4 cells that actually exist within the grid boundaries. The challenge is doing this efficiently for every single pixel without redundant calculations. The naive way is to iterate through every cell, and for each one, run another loop to check all 8 neighbors. We'd keep track of the sum and the count of valid cells, then calculate the floor of the average. This gives us a time complexity of O, m times n, which seems fine, but we're performing constant time operations 9 times for every single pixel. While it passes for small inputs, it's inefficient because we're recalculating overlapping areas thousands of times. The key insight is to precalculate a summed area table. First, we create a prefix sum matrix where each cell stores the sum of all elements from the top left corner down to that point. To do this, we add the current pixel value to the sum of the cell above it, the cell to its left, and subtract the diagonal top left cell to avoid double counting. Once this table is built, we can find the sum of any 3x3 window by taking the bottom right value and subtracting the areas above and to the left of our window, then adding back the top left corner. This allows us to get the neighborhood sum in constant time regardless of the window size. You'll recognize this pattern whenever a problem asks for the sum or average of multiple overlapping rectangular subregions within a larger matrix. The time complexity is O m times n to build the table and process the grid. The space complexity is also O m times n to store the prefix sum matrix. If you like this, try the range sum query 2D problem next. It uses the exact same pattern. Hit subscribe for more deep dives.